All right, fam, here we've got section 4.4, the very last section of this chapter. We are going to talk about, okay, so let's think about it. What graphs do you know the shapes of already? We've learned sine and cosine, and last night you learned secant and cosecant, and those are basically sine and cosine. They're just little parabolas instead of a wave, but otherwise the graphing is the exact same way. So the only other two functions that there are tangent and cotangent, and these are different. So unfortunately, it's not as similar as sine and cosine, secant and cosecant like we've learned. So I have a couple things for you to write down here. This is what the basic shape of a tangent graph looks like. This is what the basic shape of a cotangent graph looks like. Don't they look really similar? Let's talk about similarities and differences here. So both graphs have these dotted lines. Do you remember from Algebra 2 what these dotted lines are called? They are called asymptotes. They are the same exact asymptotes that you learned when you were in Algebra 2, maybe for like logs or exponentials or rational functions. Remember all those fraction graphs that you guys did? So these asymptotes work the same way. When I taught Algebra 2, I taught it as though these graphs were almost magnetized and attracted to the asymptotes, but they never actually went through them. That's the same exact way we have here. Each of these graphs has two asymptotes, so we have them for cotangent graphs also. Notice how they're in different spots. What are the x values of the asymptotes for the tangent graph? Negative pi over 2 and pi over 2. That is something to make note of. That is different from cotangent. They're at 0 and pi. Okay, so that is like thing number one, is that the asymptotes are in different places. What's the x-intercept? So in this case, where does the tangent hit the x-axis? Tangent hits the x-axis at 0. That is where I like to refer to the graph as being centered. Cotangent hits the x-axis in a different spot. Remember, there's an asymptote at 0. This one hits at pi over 2. Those are things that you need to like memorize / have written down. That's why I have like a bunch of notes out here, just to things for you to help you, similarities and differences. Tangent is centered at x equals 0, and that is because from the unit circle, if you guys take out your unit circle, if you look at 0 degrees or 0 radians, for the tangent you should have written 0, because the y over x at 0 degrees is 0. Okay? In this case, when we do cotangent and when we flipped 0, we ended up with undefined. That's why there's an asymptote right here. Keep in mind, asymptotes mean undefined. That's similar to when you were in Algebra 2 and you learned rational functions. Also, there's an asymptote at pi because the cotangent at pi is undefined. So do you have to memorize these? You kind of already do because you have them written on your unit circle. If you look at the unit circle at pi over 2, do you see a tangent at pi over 2? It should be undefined. That is where we have the asymptote. So that's where these asymptotes are coming from, you guys. Where you see the words undefined on your unit circle, you will have asymptotes there for the tangent. And if you flip those fractions, remember you get cotangents. So if you flip the 0 tangents, wherever tangent is 0, if you flip those, that gives you cotangent, and that gives you these asymptotes. Okay, so only other thing I wanted to mention, I wrote where the asymptotes are here for both of these. I want you to know that tangent is an increasing function. Remember at the very beginning of the semester, we started talking about like as theta increases, what happens to the sine, what happens to the cosine, what happens to the tangent. When we talked about tangent increasing. That was what we wrote in one of the blanks in like the very first notes packet of the year. In this case, cotangent, since it's flipped, has kind of an opposite relationship, decreasing. So a couple of things for you to have written down, and I also have some notes here before we actually do our graphs. We're going to do 3 tangent-cotangent graphs together, and here are some notes. These are going to be your step-by-step instructions on what to do if I ask you to graph a tangent or a cotangent graph. Very first thing, something very important, the period is different. The period for tangent and cotangent is pi over b. This is the formula. That's a really important difference. It is not 2 pi over b like all the other ones that we've done. I told you tangent and cotangent graphs are different. The shapes are different. They have weird asymptote things, and also the period is different. The asymptotes, how do you figure it out? So for tangent, this is the generic equation that we're going to use for tangent. It has an a value, which represents the multiplier in front. It has a b value, which is similar to what you use for the period. What you're going to do is you're going to set these two equations, bx, whatever b is in the equation. B will be a number like it's been in all the other sine, cosine, secant, and cosecant graphs we've done. So you just set that bx equals negative pi over 2 and bx equals pi over 2. Why is that, you might wonder? Well, because these are the asymptotes for tangent. What do you set the bx's equal to for cotangent? 0 and pi. That's because that's where the asymptotes are. So these are things to have memorized. Maybe write this stuff down on your unit circle if you have room somewhere that you can quickly reference it. But these formulas are going to be really important because once you have the asymptotes on your graph, it's just a little snake type of shape, increasing, decreasing, and it goes through the midpoint of your two asymptotes. So as you can see, the asymptote equations are like the most important thing about these graphs. So remember the midpoint, just like I was saying, of the asymptotes, that's the center. So if you get your two asymptotes on the graph by using these formulas, you put a dot in the middle and connect it with a snake. Here's my two asymptotes for the cotangent graph, The midpoint is where the graph goes through the x-axis. So keep that in mind. And remember, the curve approaches the asymptotes. It's like a magnet. It's approaching it. It gets attracted to it, but it doesn't ever actually go through it. Okay. Here we go with our three examples we're going to do. Y equals tangent 2x. So remember that the period equals pi over b. And the b in this case is 2. So that means that the period of this is pi over 2. And what that means is the period, let me go back up, the period is the distance between the asymptotes. It is the horizontal distance that it takes to get your snake-like figure. Okay? So that is the distance between my two asymptotes. Let's figure out actually what the asymptotes are. So I'm going to do bx equals negative pi over 2, and I'm going to do bx equals positive pi over 2. That is right from up here. Because this is a tangent graph that I'm looking at, these are the equations of the asymptotes that I'm using. And the reason it's negative pi over 2 and pi over 2 is because that's where the tangent is undefined. You can look that up on your unit circle. At pi over 2 and negative pi over 2, you should have written UND for undefined for the tangents. And so remember, my b is 2, so all I need to do is plug in 2x equals negative pi over 2 and 2x equals pi over 2. This gives me x equals pi over 4 and negative pi over 4. So that's just some cross multiplication, simple algebra, but that means I have one asymptote at negative pi over 4 and another one at pi over 4. And I'm going to put my asymptotes on there because, like I said, that's the most important and most helpful thing to put on your graph to help you figure out all the rest of the stuff. Can you figure out where the midpoint is of those two asymptotes? So right here it's 0. Awesome. By the way, we will not be doing phase shifts left or right of tangent and cotangent graphs. That would just be a little bit too mean. Anyways, let's come up with one other point. So in order to figure out whether it's supposed to be increasing or decreasing, remember that tangent up here, the tangent graph is an increasing graph. So my snake is going to look like so. Awesome. One thing I want you to keep in mind is, can you figure out what the shape of this graph would look like if I put a negative sign in front of the tangent? Then it would look a lot like a cotangent graph, right? But in that case, the asymptotes for cotangent would be here and here. So the asymptotes are different. But just keep in mind, like this example right here, this one is actually a tangent graph that looks like this, but it's going to be flipped upside down, so it's going to be decreasing. That makes tangent and cotangent shapes a little bit confusing. The asymptotes are the most important part, and that is how you tell whether it is a tangent graph or a cotangent graph. Okay, so let's go back into the second example. So what I'm going to do again, I'm going to first start out with what the period is. Remember, that's pi over b, and the b in this case is 1/2. So I'm going to do pi over 1/2. When you flip and multiply that, you get 2 pi. That means that the distance in between my two asymptotes is 2 pi. So in this case, remember the period was pi over 2. That's the distance between here and here. In this case, my distance between my asymptotes is going to be 2 pi. So let's figure out what the asymptotes are. Remember, we have those two equations. One of them is bx equals negative pi over 2, and one of them is bx equals pi over 2. And the b is 1/2. So I'm going to go 1/2 x equals negative pi over 2, and 1/2 x equals pi over 2. Okay, so essentially the 1/2s on each side cancel, or you can just cross multiply this thing. Use some algebra 2 skills. We get x equals negative pi and x equals positive pi. If you're having problems with cross multiplying and fraction work and stuff, I am going kind of quickly. I encourage you to write it off to the side or ask me about it. Eventually you'll get to the point where you can do this in your head. But my first asymptote is here at negative pi. My next asymptote is here at positive pi. So I'm going to put my asymptote dotted lines on there, like so. And just for like peace of mind, I did say originally that the period was 2 pi, and that makes sense because the distance between here and here is actually 2 pi. So that works out well. And again, my point that I'm going to use on the graph goes through right here. So how do we use like this amplitude number, this 3, how does that impact? So remember, it's negative, so that means my tangent graph is not going to have the normal increasing shape like the other one did. It's actually going to be decreasing. And the reason I know it's tangent and not cotangent is because of where the asymptotes are. We're going to do a cotangent one in a second. The asymptote starts at 0 for cotangent, but I'll get to that. But this amplitude, actually, the 3, makes it just a little bit more kinked, if you will. So if you want to, and what I could have done here is the amplitude here was just 1 and 1, so my ordered pairs go through the 1 and the negative 1. In this case, I'm just going to go up 3 and down 3. And since it's going to have this negative shape, decreasing because it's negative in front of the equation, this ordered pair actually is up 3 and this one is down 3. So this distance right here matches this number, and this distance right here matches the one that's in front of there. So that's really the only way that like the amplitude comes into play. It affects still not so much the humpiness factor like I've discussed before, but it does, play into the graph a little bit, so just keep that in mind. That's how you use the amplitude numbers. Okay, one more. Let's see, period, first of all. So it's just pi over b. In this case, the b is 2. So my period is pi over 2. That means the distance in between my two asymptotes is pi over 2. Okay, so remember, period is pi over b for tangent and cotangent, but for all the other ones, the formula is 2 pi over b. Okay, so asymptotes in this case, bx equals 0 and bx equals pi. And I'm just going to solve both of those. I'm going to plug in the 2. The b is 2. So I'm going to plug that in here and here. 2x equals 0 and 2x equals pi. This means x equals 0 when you divide by 2. This means x equals pi over 2. Those are my two asymptotes. So one of them's at 0. Go ahead and put my dotted line right there. That, my friends, is the difference between tangent and cotangent, okay? Both of these tangent graphs that we already did, notice, at 0, there's an actual point there on the graph. That will be true for tangent, because tangent of 0 is 0. In this case, for cotangent, there's an asymptote on 0. Huge difference. Different from tangent versus cotangent. So you're not going to put a point there, because the cotangent of 0, when you flip the fraction of 0, you get undefined. That means asymptote. And my other asymptote goes at pi over 2. So I'm going to put my other asymptote there. There's my dotted line. Can you figure out what the midpoint is? Between 0 and pi over 2 would be pi over 4. You just cut pi over 2 in half. And so that is where my cotangent graph is going to go through. And remember, cotangent graphs, this is a positive cotangent graph, so what is that supposed to look like? It's right here. It's supposed to be decreasing. Cotangent graphs are decreasing. Unless there's a negative in front of it that flips it upside down, but in this case there's not. So it's a decreasing graph, and it goes right up alongside the asymptote but doesn't touch it. How do you use this 1/2? Technically, If this is 1 and this is -1, that means my ordered pairs are actually at 1/2 and -1/2. And that's how you use like that amplitude number. It's good to note that tangent and cotangent don't have actual amplitudes. I'm going to write that. But I refer to that A value as the amplitude number because it does kind of affect those ordered pairs. But keep in mind that an amplitude, what we defined amplitude as, is a distance. And since tangent and cotangent both go up and down forever, there isn't a distance. So keep that in mind. Technically, it's not called an amplitude, but it does affect the way that you do your graphs a little bit. It's just your little y values in this case. So this is 1/2, this is -1/2. That's all for tangent and cotangent graphs, you guys. We do have a test coming up soon in about a week or so. We're going to do a lot of practice and make sure you bring your questions to class and you contact me if you need some help or if you don't understand something, okay? Good job. Congratulations, made it through the packet. See you guys.